Rules of transformations. Please refer to your reference materials and your vocabulary. Okay, rules of transformations. Please use your calculator to verify all this information. Make sure you're typing it in properly using parentheses where appropriate, and you'll see how to use technology to help you solve problems involving transformations. Please also note that you will have to understand, without the use of technology, what each one of these properties does, and so understand how it works without the use of technology as well as with. Let's reverse that. A minus will give you a shift down d units. Addition will give you a shift up d units. When it is inside parentheses with the x, you are thinking opposite of what actually is going to occur. A negative symbol typically means we move left in mathematics. However, it's the opposite. You will be moving right c units. This is left c units. This is what is known as a vertical stretch. This is a vertical compression. When it is inside of the parentheses, the multiplier, you get a horizontal compression when the value of b is larger than 1, and a horizontal stretch when it is a fraction. Please verify all of this in your calculator so that you understand what exactly is happening when you do this. When it's negative outside, you get a reflection across the x-axis. When it is inside, you reflect across the y-axis. All right. Now, when there are multiple transformations in a single function, make sure you move from left to right. We'll be doing that now. First, I will list the transformations, followed by each single transformation in a different color, and then I will give the final transformation again in black ink. Okay? So first thing we're going to do is reflect the x-axis. Second thing we're going to do is vertically stretch. That's the 2. The third thing we're going to do is move it up 1 unit. That is plus 1. Okay, first things first, let's reflect. So everything that's negative becomes positive. Everything that's positive becomes negative. Alright, let's go ahead and utilize a different color. This first one will be in red. Alright, a vertical stretch of a factor of 2. So this is going to be multiplied by 2. That will be multiplied by 2. That and that will be multiplied by 2. This will be multiplied by 2 up to 8. And this will be multiplied by 2 up to 4. Utilize a different color. A different color, thank you. then finally, the last transformation will be to move the green lines up 1 unit. Here, here, there, there. This will be moved up to there, this up to there, and this moved up to there. And my final is the dark black. Okay, absolute value. Absolute value is a parent function, and absolute value is a transformation. So please note that when absolute value is used as a parent function, you do not also use it as a transformation. This can be confusing. I will clarify it when it comes up in the future. Okay, if absolute value is being used as a transformation and the absolute value is around the outside of the entire function, that means the graph will only have positive y values, okay? The graph will only have positive y values. Okay? That means that all negative y values, such as in example 8, will be reflected up to the positive y value. And this comes right along with it. Okay, we'll connect those lines. Notice that this remains part of the function. Absolute value as a transformation is a little bit confusing. Just remember that all negative values transform or get changed to positive values. Okay? Alright. Moving on down to number 9. Here we go. Okay. What happens here is the graph will only have positive x values. It's a little bit more complicated, so I want to make sure that you understand what you're looking at here. All negative x values will be removed. And they will be replaced with their positive x value counterparts. So essentially, you will reflect all negatives over the x-axis when you're transforming this, and you will be reflecting all x values over the y-axis when you are transforming this. Confusing? Yes. We will work slowly through this one. I will draw a table which might help clarify what I'm talking about. If you see the reflection, the table is not necessary. So what we'll do first is we'll fill in the original x and y values for this particular function, okay? -4, -1, -3, 0, -2, 1, -1, 2, 0, 0, 1, -2, 2, -4, 3, -3.5, 4, -3, and 6, -2. Now we will fill in a transformed table of all of the negative x values, okay? So remember, the transformation in this problem is to take the absolute value of x. The resulting y value will be its positive counterpart. So here we go. The absolute value of -4, because remember, we're only going to focus on these 4 negative values. The other ones do not change, just the negative ones, because that's the value that absolute value actually changes. So the value of -4 as an absolute value becomes +4. Now, when you're looking at this, we have to find 4. That's -4's positive counterpart. Okay, so 4 is -3. That's right there. Okay? -3 becomes +3, the absolute value of 3. And 3 is -3.5. Okay? -2 becomes 2, and 2, its positive counterpart, is -4. Down here, -1 is 1, and its positive counterpart is -2. Okay, now what does that mean? That means that instead of writing these 4 numbers, I will be replacing them with these 4, and then continuing on here. However, if you see the transformation is this. This part of the graph disappears. This part of the graph is reflected across the y-axis, like so. Okay? This is the new transformed function, including this and excluding that. Complicated? A little bit, but we'll make sure that we take a look at it in more detail in class if you have more questions. Okay? Now what we'll do for the remainder of this is take a look at all of the transformations that we could see and all of the different formations that they could come in. Okay, remember, absolute value transformation is applied last. Therefore, in order, I will start with down 2, which is your -2 outside of the function. Okay? Followed by a reflection of negative y values across the x-axis. Reflect negative y values across the x-axis. Okay? Likewise, we'll start with the first set of transformations, and absolute value will come last. So that is a vertical stretch of 2. That is right 1 because it's inside the parentheses, and that will be down 3/4 of a unit. Okay, finally, the negative x values will be removed, and all positive x values will be reflected across the y-axis. So remove negative x values, reflect positive x values across the y-axis. Okay? Now we're going to write an expression using the general term h of x. Vertical compressions are multipliers in front, so that's going to be 2/3 times h of x. Okay? A horizontal translation is moving left and right, so that's inside the parentheses, opposite of what we think, so that's why it's +2, with a vertical translation up 7 plus 7 outside the parentheses. G of x is a transformation of f of x. Write the expression. Okay, so what we've got to do here is we've got to look carefully at the critical values. This is a corresponding critical value to that corresponding critical value. 1, 2, 3, 1, 2. So it took me to the right 3 and up 2 to get from that corresponding value to that one. It doesn't look like there's a different stretch, because if there was, you would notice a different slope, and these lines appear to be parallel to one another. No reflections have taken place, so it is a simple right 3 up 2 transformation.